Good morning, everyone. Thanks for coming this morning for this session. My name is Bill Fotopoulos. I am the Global Marketing Manager for Perfusion Circuits at Terumo Cardiovascular. And we are excited to talk to you this morning about the CAPIOX NX19 oxygenator with UltraPrime technology. This morning, the presenter will be Karen Rosenberg. She's a Principal Clinical Specialist here at Terumo for perfusion products. So, Carol-Ann.
Good morning, everyone, and thank you for coming to have breakfast with me. I'm very honored, and we are honored to be here to present this really exciting new technology from Terumo. So, as Bill had said, that we're going to talk about the NX19 oxygenator with UltraPrime technology. A little video to start the presentation off.
Terumo Cardiovascular Group introduces the CAPIOX NX19 oxygenator with UltraPrime technology, our smallest, most advanced full-size adult oxygenator with only 185 milliliters of prime. Building on Terumo's oxygenator legacy, the CAPIOX NX19 oxygenator takes oxygenation to the next level. Let's take an up-close look at the features of the device. The CAPIOX NX19 oxygenator features the popular CAPIOX Advanced Reservoir with low minimum operating level, enhanced flow dynamics, stable smooth blood flow path, and a separate cardiotomy filter with low holdup volume. The CAPIOX NX19 oxygenator is easy to use. The blood inlet port configuration options provide the clinician with a choice for circuit optimization. This feature aids in minimizing tubing lengths, thereby reducing circuit prime volume. The new bidirectional water port design makes waterline connections simple. The CAPIOX NX19 now features an auxiliary gas outlet port for capnography sampling. The Prime Assist feature and original self-venting technology ensures excellent gaseous microemboli removal. The responsive design of the highly efficient heat exchanger is ideal for any procedure type, including circulatory arrest. The hollow fiber and unique woven pattern reduce surface area while delivering high gas exchange performance. Let's take a closer look inside the CAPIOX NX19 oxygenator. Priming and de-airing the CAPIOX NX19 oxygenator is fast. First, water fills the heat exchanger through the bidirectional water ports and flows on the inside of the polymer capillaries. Next, prime solution enters the oxygenator. As fluid fills the heat exchanger and fiber bundle, air rises to the top of the device and exits through the Prime Assist port. CAPIOX NX19 oxygenator features a new patent-pending air removal technology. This hollow fiber technology-placed pre-heat exchanger removes air and prevents it from becoming trapped inside the heat exchanger. Blood enters the inlet port axially and is then distributed radially through the heat exchanger where it is heated or cooled. Blood exits the heat exchanger and continues along a radial path through the oxygenator fiber layer where gas exchange takes place. The proprietary smaller fiber, woven in a unique pattern, provides optimal blood-to-fiber contact, resulting in increased gas transfer. Blood flows on the outside of the hollow fiber, while gas flows through the inner lumen. Terumo's self-venting technology acts as a continuous purge, removing gaseous microemboli. To provide the safety of arterial filtration, the CAPIOX NX19 oxygenator has an integrated arterial filter. Terumo Corporation's new CAPIOX NX19 oxygenator provides highly responsive warming and cooling, low prime volume, less foreign surface area, excellent GME removal, and optimal oxygen delivery. It is the unique, optimized combination of proprietary materials and technology engineered to perform without compromise. That is UltraPrime technology. And only CAPIOX NX19 Oxygenator has UltraPrime technology.
All right. Sorry. So as the video had alluded to, the CAPIOX NX19 with UltraPrime technology is engineered for ultimate performance. So it's 185 ml prime volume with a 1.9 fiber surface area with the integrated arterial filter, advanced reservoir as similar to the FX15 and 25, and the X-coating surface. So with the UltraPrime technology, it's engineered for the ultimate performance, as I said. It has that 185 ml prime volume, the 1.9 surface area. It is 8 liters of blood flow, which is our highest rated flow oxygenator in our market. So integrated arterial filter, advanced reservoir, X-coating, and as you can see, there's an auxiliary port that can be used for capnography if chosen. So it's easy to use. It has bidirectional water ports, and that now they are also, instead of being on the side of the oxygenator, they are underneath the oxygenator, which if you have surgeons that are going from side to side of the bed, it reduces the risk of knocking into the oxygenator. And then it also has this Prime Assist feature now, which is actually in the middle of the oxygenator to help de-air the oxygenator versus where originally was off to the side. As the video alluded to, the hollow fibers, they are smaller and they are more powerful. So it is new proprietary hollow fibers. We continue to be the only oxygenator whose company makes the hollow fibers within Terumo, so that we're able to design them as we need them to be to work the way that we choose them to work. So the fibers are new, they're different from the other manufactured fibers that we've used before. They are smaller, they have a unique winding process, and they allow for more fibers and layers in a given space. So the heat exchanger, as mentioned, is highly efficient, and its responsive design is ideal for any procedure type such as circ arrest. So this is actually a really exciting slide that I like to show. And so it shows the actual hollow fibers themselves, where you can see that they are now smaller and they are more powerful for better gas exchange. So the block that is on the right, you can see there's 4 hollow fibers. And now on the left, you can see that there's many more. So by Terumo optimizing those fibers, looking at, how can we get more of them in there so that we can decrease the shunt fraction, so that when blood is going into that oxygenator, we can be assured that it is very difficult for the blood to not get some sort of a gas exchange while it's traveling through the oxygenation path. So as you can see, when the third block down, with those more of those hollow fiber capillaries, you can see that the blood is very difficult for it to travel in and travel out without having gas exchange. So the result that we have too with the reconfiguration of the hollow fibers is that we have a very low prime volume, high gas exchange, and it flows up to 8 liters. So this is the NX next to the FX hollow fiber comparison. So the surface area of the FX25 is 2.5, whereas the CAPIOX NX19 is 1.9. Sorry, the outer diameter is 295 and it's 171. Basically, at the bottom, you can see that the number of fibers for the NX19 is 42,000 fibers compared to the 13,000 that the FX has. And so if you were to take those fibers and go end to end, the NX19 would have 2.2 miles of fibers. So as you can see, it makes it very highly, it decreases the shunt fraction, and it allows to ensure that that blood will be oxygenated as it goes into that oxygenator and out. So we have patent pending air technology removal. We are confident in the GME removal. We have pre-heat exchanger air removal technology. And so basically with the polymer oxygenator, before it actually even enters into the into the heat exchanger, that there is technology that Terumo has been able to create that removes the air before it even enters into the actual heat exchanger itself, and it is vented out. So basically, it's provided safe arterial filtration, less foreign surface area, and no added prime volume for that as well. So, and then also, as we mentioned, we have the Prime Assist feature that allows us to efficiently remove air without tapping and manipulating with the FX series, where the Prime Assist was off to the side. People would, there would be air that might hang up there. It may be a little bit more difficult to de-air. So the GME removal efficiency was a test that we did in the lab. The test specifications are off to the side there, but essentially they took 30 mLs and injected it into the oxygenator in 0.5 seconds. And so they basically, over 5 minutes, they did 10 samples, and they were able to show that the GME that they had the maximum counts, 20, so that makes sense, right? Because 32 micron filter within the oxygenator itself. And we also know that 20 microns, from 10 to 40 microns, the GME is considered small, and at sometimes in some research papers, it's considered noise and not necessarily significant. So as you can see that the GME counts are at the flow rate of 8 liters is very small. So highly efficient heat exchanger. Those of us who have tried to decrease prime volume, sometimes we do it at the risk of or the sacrifice of time that it takes to rewarm your patient from a circ arrest back to normal thermia. And so as you can see, as I tested, that going from 18 to 35 degrees, that it took an hour and about 7 minutes, whereas if it was looking at the FX15, it's going to take you at least 20 minutes longer to warm. So being able to come off bypass is definitely a win-win for the perfusionist, the patient, and the surgeon who is answering to remove the patient from bypass. So we all know the risks of cardiopulmonary bypass. And so this oxygenator we've proven that it is a lower prime volume and less foreign surface area and gaseous microemboli removal. And so these were the key design addresses when they were creating this oxygenator. So this is a paper from Dr. Lepar that basically talks about blood reduction conservation is improve outcomes and reduce costs to the hospital. So not only is being able to reduce blood utilization a win for the patient, but it is also a win for the hospital in terms of dollars. And so the effects of the priming, this is a paper from Dr. Ranucci, basically that we need to do everything that we can as perfusionists and as vendors to ensure that we are lowering the prime volume of all of our circuits. So basically a small reduction in prime volume is basically a significant clinical benefit, right? So every amount of prime volume that you can subtract from your circuit. And when I say subtract, I mean truly subtract from the circuit. It's not, we're taking it from one area, but then we have to add it back somewhere else. This is prime volume within this NX19 that has been totally removed and not added anywhere else in your circuit. So he's saying that even a relatively small decrease is definitely a win for the patient. This is another one by Ronson, and basically it's just saying prescriptive patient oxygenation reduces hemodilution and blood transfusion in adult cardiac surgery. And so we all know that basically by decreasing the amount of hemodilution is going to decrease the potential for a transfusion, which will, like as we said in the other paper, it'll decrease the amount of spending for the hospital and also the mortality morbidity of the patient. So this is the STS and ANSEC guidelines, basically, that are telling us, they're the updated ones, that are telling us that we as clinicians need to do everything that we can to ensure that that patient is going to have the least amount of prime volume, decreased hemodilution for better outcomes. And so they talk about wrapping your patient, retrograde autologous priming, and also looking at mini circuits and reducing the prime volume. So Terumo has made it their goal to ensure that we are be good stewards of this information and developing disposables that actually fit to what we're being told how to practice. So this is a clinical evaluation of the NX19. It was a multi-center study that was done in Europe by Mr. Hendricks' group. And basically, they had 150 oxygenators that they distributed amongst 3 different hospitals. Each hospital had 50. They were done with cabbage valve, or just a valve. They were, in this study, Mr. Hendricks had told them that, here's the oxygenator. I want you to incorporate this into your circuit, and I want you to conduct your cardiopulmonary bypass as if this was yesterday and you had your chosen oxygenator in there. And so I don't want you to change anything that you're doing. So he wanted to see how those 3 hospitals fared with this oxygenator in their circuit in the way that they practice. So that includes, the prime, the way that they would prime, their technology, how they prime, what they put in their prime, how they de-air, all of that. So however they practiced yesterday is the same how they're going to practice during this study. These are the parameters that they were looking at. And so this is the gas exchange, and they use the CDI 550 to show the gas exchange, and what they were able to show is that the shunt fraction has decreased significantly from the FX25. And that is what means that the blood that's going to come into the oxygenator is highly likely that it is going to have gas exchange before it is removed from the oxygenator. And as you can see, it went from 0.32 to 0.19. That is a significant decrease, meaning that gas exchange will happen within that oxygenator. And so as you can see, they increase the O2 transfer and the CO2 transfer as well. And so there's the little diagram. As you can see, we increase the amount of hollow fibers that we have, so that that helps us to decrease that shunt fraction. So this is the heat exchanger performance. The FDA has regulations as to how our heat exchanger needs to perform. That is in the IFU, and that they were able to show in vitro that it actually performed better than we stated in the IFU at 3 liters and 6 liters. So the heat exchanger was not necessarily part of the evaluation, but they figured that since they were there, they should look at it, and so they did an in vitro study. So this was the O2 transfer slope. So remember, this was 3 different centers within Europe that practiced the way that they normally would practice, but what they were able to show is that between 230 mLs a minute of oxygen consumption with an FiO2 of 40 and 60, you will see in the red that Antwerp is a little bit more over to the left, and they're saying that that has to do with Antwerp had patients that they were had colder temperatures than the other 2. And also one of the things that they had talked about, but they didn't do the research, is the depth of anesthesia. So like I said, these oxygenators were given to this multi-center study to the 3 different hospitals, and they were told to practice as they normally would practice. So GME removal, this is a pretty exciting slide. You can see the pre and the post oxygenator between the 3 different centers there. And those are the counts. This was during the prime. This is not during bypass. And so you can see that the difference in the values between 52, 43, 94, and that they attribute to the fact that, the difference in priming technology, what level, the minimum operating level for the reservoir is 150 mLs. So, they don't know, how they didn't talk about how they primed or what was in their prime. They did talk about what was in their prime, but it was different between all 3. I know that what was interesting is Antwerp actually CO2 primed their circuit, and the other 2, or did not CO2 prime their circuit, I'm sorry, and the other 2 did. So as I said, the practice was how they would normally practice. The exciting part is that when you look over at the pre and the post oxygenator, this is in microns. So when you look at GME, a lot of the papers will say anything from 10 to 40 is considered a small GME, and that they are not sure what to make of it, and that it can be considered noise, and a lot of times it's discredited. So you can see that the 0.6, the 0.06, the 0.04, 0.00 is well below the 10 to 40 that we consider small GME. And so you can see the removal is significant, and this is during the prime phase. So the polymer versus the stainless steel heat exchanger, the reduction of thermal shock in polymer heat exchanger, thermal shock being that the stainless steel is going to warm and cool your patient on the surface, whereas these polymer fibers are going to actually warm and cool the blood throughout the entire fiber itself. So that helps with the potential of thermal shock. So we have improved biocompatibility, reduced thrombogenicity, and we have normal fibrogen, and only a small decrease in platelet count is what this multi-center study showed. So the gas pressure resistance, we were able to show that even though we took those hollow fibers and we made them significantly smaller, that we still have the same great diffusion that we need for gas transfer. And that they're basically, the resistance is slightly better than most oxygenators, and that the resistance is very comparable to FX25. So for the gas pressure and resistance, you can see here that, oh, I did this one. I think I did it again. Sorry, guys. So the shear stress for the CAPIOX NX19, you can see is 5.1. It's a little bit higher than the other ones there, but as you can see that the results are still far below what is associated with red cell hemolysis, which is about 2,000 to 3,000 dynes per centimeter. And then platelet activation, of course, is between 75 and 100. So the shear stress is a little bit higher, not significant at all, because it is well below what would be considered for hemolysis. So the clinical evaluation of this multi-center study, basically the summary of findings is that the polymer heat exchanger improves heat exchanger performance. Air removal technology removes 91% count and 94% volume of the GME. And so the incorporation of smaller gas fibers results in decreased priming volume, enhanced gas transfer efficiency, little effect on the gas inlet pressure and resistance, and acceptable shear stress. And so that is the end of the presentation. Any questions?